Okay, in this video we're talking about acceleration. I think most of the time whenever we think about acceleration, we have this idea that acceleration is just moving, whenever we start moving faster, and that is just going in the forward direction. So I want to kind of readjust what you think of acceleration and readjust your definition of acceleration. So if we look, I think it's important to define it first. So if we look at acceleration, it's simply the rate of change of velocity. So these are kind of the key words here. The rate at which we change velocity is the definition. So whenever we think about acceleration, I want you to think about what this actually means when I give you guys some examples here. I think it's also important to discuss the differences between kind of speed, velocity, and acceleration, because sometimes we get velocity and acceleration kind of mixed up a little bit. Like in the bungee example that I gave you guys, the guy bungee jumping. Speed, if we look at it, we got to look at whether it's a scalar or vector again. So speed is a scalar quantity, so that just means that we look at the quantity, right? Or the magnitude in that case. So it could be like 23 meters per second. Velocity, on the other hand, velocity is going to be a vector quantity. So we not only have to know the magnitude or how much, right, like 23 meters per second, but we also need to know direction. So we could say it's going west. Acceleration, because acceleration is the rate of change of velocity, it is also a vector quantity because we need to know direction. So if we change anything about velocity, then we are accelerating. So that would be like 23 meters per second every second. So we could write it like that for our units, or we could do meters per second squared for our units. So every second we are changing our velocity by 23 meters per second. So if we were to, let's kind of do some examples here. If we were to change, if we were to go faster and faster, if we increased our speed, so these are, here, let's just write it like this, 3 ways that we can change, 3 ways to change acceleration. Or acceleration. Can't spell right now. So 3 ways to change acceleration if we increased velocity. So this is kind of the main way we think of acceleration. If we increased velocity, would we be changing acceleration? Yes, because we are changing the velocity at that point. If we decrease, so if we started slowing down, if we were driving in a car and we slowed down, would that be us accelerating? Yes, it would. Because again, look at the definition. It's the rate of change of velocity. It doesn't matter if you're speeding up or slowing down, you're still accelerating. Sometimes we call that deceleration. So also the third way is if we, and this is kind of the way, one of the ways that we don't really think about, are we accelerating, if we change direction. So because we have to know direction in velocity, then if you change that direction, so if you start driving around a corner, are you accelerating? Even if you're going at constant speed or constant velocity, so even if you're going at constant velocity at one velocity around that corner, because you're changing direction, you're also accelerating. So those are the 3 ways we accelerate. So if we look at our definition, we can kind of figure out what our equation is for acceleration. Our equation is A for acceleration is equal to our change. So remember, the delta means change in something. So the change in velocity over the change in time. So the rate of change of velocity. So how much did velocity change over time? But this is our equation that we're going to use to solve some of the problems. And you may want to write those in your notes. You may also want to have the 3 ways that we can accelerate. Okay, so doing some practice problems here real quick using our formula that we figured out. So the tune train is traveling at a speed of 10 meters per second at the top of the hill. 5 seconds later, it reaches the bottom of the hill, moving 30 meters per second. So here is a velocity, and it takes 5 seconds to get there. So there's our time. What is the rate of acceleration of the tune train? So we just got to plug these numbers into our formula here. So it starts out, our initial velocity would be 10, right? So that would go right here. Our final would be 30. So we have 30 minus 10 meters per second. And then our time, it would be 5 seconds. So what is our initial time? 0 minus 5. So 5 minus 0 would just give us 5. And then we would have 20 for our meters per second. So 20 divided by 5 would give us 4 meters per second squared. So how do we get our units on this one? Well, if you think about it, up here we have meters per second, right? Because these are our velocities. Down here we have time, which is seconds. So meters per second divided by our time. So we put another slash in there and we get another S. So really it would be like this, meters per second divided by our time would give us divided by another second. But we can just write that as meters per second squared. Okay, so I want you guys to, I'm going to give you guys a couple practice problems. Right here you can see Pete the Penguin, Monster Mike's truck. I want you guys to solve those. Using the formulas. All right, good luck, and hopefully this was helpful. I'll see you guys in class.